The error code PC10 in air conditioning systems, for most brands, indicates an anomaly in the voltage supplying the outdoor unit, known as the condenser in cooling mode. The error code PC10 is generally displayed due to low voltage protection. This means that the air conditioner is receiving a voltage lower than normal, which can put its internal components at risk. For example, most units powered at 220 volts are designed to operate within a voltage range of 170 to 260 volts. If the voltage falls outside these limits, in this case below, the system activates the PC10 error as a safety measure. Let's look at the steps to solve the PC10 error. A. Turn off the unit and disconnect it from the power supply. B. The first step is to check the voltage. To do this, use a multimeter on the AC voltage scale. Check the voltage value coming from the external power supply. If the voltage is too low, this is likely the cause of the error. If the unit is installed in an area where voltage issues are recurrent, consider installing a stabilizer to protect your air conditioner. A stabilizer regulates the voltage that reaches the unit, ensuring a constant and adequate supply, which will prevent the PC10 error from recurring. C. The second step is to check the firmness of the connections and the condition of the power cables. Loose connections or damaged cables can create electrical resistance, which can affect the supply voltage value. D. The third step focuses on the PFC circuit and the IPM electronic module, which are crucial for efficiently converting the AC supply into DC, and any significant deviation in voltage can cause operational problems. Therefore, we will connect the electronic board and measure the supply to the IPM electronic module. Under normal conditions, the DC voltage between the P and N terminals of the IPM electronic module should be approximately 310 volts in standby mode and 380 volts when the unit is in operation. If the measured voltage is less than these values, a PC10 error will be triggered. If the supply voltage to the IPM electronic circuit is not correct, the fault should be focused on the PFC module and the rectifier bridge. E. To find faults in the rectifier bridge, disconnect the electronic board from the power supply. Measure the resistance between any pair of the 5 terminals of the rectifier bridge. If any of the resistances is close to zero, the rectifier bridge is defective and needs to be replaced. You can also use a multimeter in the diode setting. Place the red probe on the negative DC output terminal, terminal 5, and the black probe on the AC power input terminals, terminals 1, 2, and 3, one by one. The voltage between terminal 5 and terminals 1, 2, and 3 should be the same and, in this case, close to 0.378 V. If it measures 0, the rectifier bridge has failed. Reverse the probes and repeat the process. The voltage between terminal 4, positive DC output, and terminals 1, 2, and 3 should be infinite. A value of 0 indicates a failure in the rectifier bridge. F. If the diode bridge of the electronic board is not an integrated circuit, but a set of 4 independent diodes, you can test each diode individually. To do this, use a multimeter on the diode scale. You can verify that the multimeter will indicate conduction in one direction, manifesting as a voltage value, while swapping the multimeter leads will not show conduction. G. If the voltage delivered by the rectifier bridge is correct, The fault should be focused on the PFC module. To check for faults in the PFC module, it is advisable to focus on the condition of the IGBT transistor, the recovery diode, electrolytic capacitors, and tracks. H. If the IPM module has the correct voltage supply, then the problem could be with the IPM electronic module itself. Now let's look at some steps to diagnose it. 1. Disconnect the equipment from the power supply. Remember that capacitors can store current. Use a multimeter on the DC voltage scale to measure across the capacitors and ensure they are discharged. 2. Locate the IPM electronic circuit. The IPM electronic circuit is covered by heat dissipating fins. Its pins are connected via 3 independent tracks and an electrical connector to the 3 compressor pins. 3. Positive power supply. Identify the high voltage positive power supply of the IPM electronic circuit by tracing the positive track from the largest high voltage capacitors to the IPM electronic circuit. 4. Negative power supply. Identify the negative track from the capacitors to the IPM electronic circuit by tracing the negative track from the largest high voltage capacitors to the IPM electronic circuit. 5. Identify the output points U, V, W. These can be identified by following the tracks from the compressor connectors to the IPM electronic circuit. 6. Set the multimeter to the diode scale. 7. The IPM electronic circuit is internally composed of 6 IGBT transistors, each containing a diode that we will test. Let's start with the integrity test of the first 3 diodes. A. Place the black probe of the multimeter on the positive input of the IPM electronic circuit. B. Use the red probe to measure the points U, V, W. C. The minimum voltage activation values should be around 0.45 volts for each measurement. D. The measurement obtained between the negative supply and each pin U, V, W should yield practically the same reading. Let's proceed with the integrity test of the last 3 diodes. A. Place the red probe of the multimeter on the negative input of the IPM electronic circuit. B. Use the black probe to measure the points U, V, W. C. The minimum voltage activation values should be similar to those obtained previously. D. The measurement obtained between the negative supply and each pin U, V, W should yield practically the same reading. If everything seems fine with the IPM electronic circuit, you can perform the following test. A. Connect the electronic board to the power supply, taking the necessary precautions. B. Set the multimeter to the DC voltage scale at 400 volts. C. Place the red probe of the multimeter on the positive power supply of the IPM electronic circuit. D. Place the black probe of the multimeter on the negative power supply of the IPM electronic circuit. E. The power supply value will depend on your electronic board's power supply, expecting values around 150 volts for a 110 volt supply and approximately 300 volts for a 220 volt supply. F. If no power appears, the issue with the external electronic board lies in the power supply, and not directly in the IPM electronic circuit.